Chapter 27 Ranged Missile Spells, in which the creatures get to shoot missiles. Motivation. Our creatures can fight with weapons in melee range. They can also cast an assortment of duration debuffs. But we don't yet have any way to fire missiles at range. Ranged combat adds variety and opportunities, and often simply has a nice feel to it. We want to be able to point in a direction or at a target and blast away at stuff. Balance and limits. If we could point anywhere and keep firing at everything, it would unbalance the game, not least relative to other abilities. We need ways to constrain a ranged ability. One traditional limit regards which directions are possible. Maybe you can only fire in the 8 cardinal directions or in 8 directions. Another limit is some kind of cost. Maybe shooting has a cooldown of 21 turns. Maybe it eats your mana. Maybe you can only shoot the number of charges your wand holds. Maybe you can only shoot out to a limited distance. Maybe the strength of the hit depends on how far you shoot. A long-range shot could either be stronger, accelerating, or weaker, losing momentum. Possibilities. Our initial goal is a specific kind of bullet shooting. Once we have such a mechanism up and running, we can reuse the same principle for totally different things. Shooting arrows and crossbow bolts, throwing ordinary items, launching a summoned monster or helper creature, launching ourselves across the room, pushing an enemy away from us, ejecting a stream of lava, ice, electricity, gas, fire, dragon's breath, or water, disintegrating rock, or magnetically pulling things closer. The plan. Our initial spell will be the so-called magic missile. It will share implementation with Firebolt, Frostbolt, and Lightning Bolt. It will fire in a specific north, south, east, west direction. In principle, we could make it just fire and then immediately hit, reporting what it hit. However, for the humane experience, we'll instead implement it as an animated bullet moving one cell at a time. Approach and mechanism. There are no laws dictating how a missile spell has to function, but we have some ideas about how ours should work. We intend it to do a sort of crude animation. We'll introduce and display a projectile in the map. We'll make this projectile do a moving animation across the screen. We'll alternate between drawing a bullet character on the screen, then erasing it again before drawing it in its new position. Once the bullet either hits something or is otherwise exhausted, we'll remove it again. We'll need to make the animation neither too fast nor too slow. A complete bullet trajectory should not take more than 1 second. Let's assume we on average shoot 10 tiles. This suggests each animation step should take around 100 milliseconds. For now, we'll go with such a fixed animation interval. But consider that you could instead work with an accelerating bullet speed. This way, short-range shots could still have a smooth slow speed without unduly dragging out far-range shots proportionally. That is, a shot 4 times as long doesn't have to last 4 times as long. We haven't done animation before now. All our game turns have been done as single-take updates with the screen only redrawn once. To achieve animation in the way we now intend, we need to split up our turns into some kind of multi-step affair. We'll introduce a new helper screen to handle our animations. This new screen will be provided with a kind of stepper iterator. The screen will continuously prompt the stepper for a next step and draw the changes until the stepper reports that it's done. Design. The screen will be called Step Screen. We will hook it up with a periodic interval timer, which fires, for example, every 100 milliseconds. At every timer pulse, the stepper is prompted to update the game state. Once the stepper says it's done, the step screen pops back off again, and we're back to the normal game screen. Note that the step screen will not react to user keyboard input. It only reacts to timer events. There's a caveat here. we could support some kind of break or escape to allow the player to get out of erroneous infinite loops, but that's a fight for another day. So what is the stepper then? Well, it's very much like our existing game commands. The difference is that the stepper can be called repeatedly and will report once it has completed. We'll design a general step interface and implement some kind of bullet step. Consider that even though we will initially use the animation step screen for a bullet animation, it has no limits as such. It might as well be used for a nuclear fireball flooding spell that expands in all directions. Our bullet step, whichever way it ends up working, will have roughly 3 phases. An initial phase that launches the bullet at the appropriate starting direction and at the appropriate starting position. Then a live travel phase where the bullet continues to travel through the landscape, one character cell at a time. Finally, an impact phase where the bullet encounters either a victim or a wall, which causes it to explode, to do damage and to stop. The rules for the bullet are up to you. Instead of stopping, the bullet might instead bounce and ricochet off some surfaces, so that the player might even hit himself if he shoots carelessly. A bullet spell. In our first efforts with these spells, we will outfit the player with a simple missile spell. This gives us an easy way to test it. Later, we will probably revoke that spell from the player again. It is simply too powerful and unrestrained. We will instead then give him other spells which will be suitably restrained in some way, so he can't just blast up the entire dungeon willy-nilly. The player will press a key to activate the spell, but which way should the missile then fire? We'll have to prompt the player first for direction. Luckily, we already have the directory command screen back from our door opening days, so we can simply pass our bullet spell to that screen. So to pass player, we will add this switch case and these methods. Our spell will be the bullet command. It should activate a step screen with a bullet stepper, and that stepper must be initialized with the player's current position and the direction that the direction screen chose. Thus, 27 bullet command will be this. That glyph.bullet doesn't exist, so let's add it to 07 glyph and 16 glyph inf1. We'll need to account for the step screen and those stepper paths we used. For steppers, the step commands, we define this interface, the 27 step if. And we define the timed step to be this. The step screen, which works with step if, will look like this in 27 step screen, TS. We'll need a sprite mechanism for the animations the steppers do. So in map cell, we will add this extra sprite field and we'll get an updated glyph method to render it. We must then update drawMap 18 with these changed parts. The idea here being that we ignore the reduced far drawing mechanism whenever there's a sprite to draw. This is a design choice. You might as well decide that sprites shouldn't be drawn outside the visibility range. Now we can make the actual bullet step using the sprite mechanism. And we'll also need the blast step to do damage if the bullet hits. And it looks like this. And here we also introduced the enumeration school, which is the kind of magic school. The timing mechanism. For our animation mechanism to function, we must extend our existing framework with a timer aspect. First, we make the O4 Event Manager class respond to timings. And for this, O4 Raw Screen IF must be extended with an onTime method. And then in O5 Stack Screen, we add this bit. And this then ties into the extension of O5 Screen IF that looks like this. And now this requires us to have an empty placeholder on time in our screens, particularly in O9 base screen. And we'll need to do fix-ups for raw test screen, stack test screen, map screen, dummy screen, and OS screen. With all these parts, Event Manager will now receive on-timer events and forward them to the stack.onTime. It will then forward them to step screen on time. That's the connection that brings our animation mechanism to life. Now that we have all the pieces, let's add a keyboard command to parse key command in O9 parse player. So the player can access the command by pressing M.